Hello everyone, for this tutorial video, I would like to explain cylindrical coordinates, which are the more easier method of bringing polar coordinates to 3 dimensions. In particular, if we remember that a cylinder is simply a circle with height, it follows that we already know how polar coordinates work for circles in 2D, so we see this carries over to cylindrical systems, where the only difference is that we have a third variable, the height, which is simply a constant number that does not depend on any trig functions. We see, because we already proved, for 2D polar coordinates, they can convert back and forth between rectangular and polar coordinates using trig. It follows you can do the same thing for cylindrical coordinates, because of how the r and degree are the same exact as in the 2D polar coordinates. So if we are given r equals 5, this would be a circle with a radius of 5 that does not have any height to it. But if we are given something more complex, like r squared plus z squared equals 100, we would plug in r squared equals x squared plus y squared, and see we get a sphere with a radius of 10 because 10 squared is 100. If we have something like this, where z equals r, then we see we get in terms of r squared by squaring both sides. So z squared equals x squared plus y squared. And this gives us a cone when we graph it out. Because of the fact the r is greater, the higher up you go. Now that we have figured out how cylindrical coordinates work, we can discuss the more complex type of polar coordinates in 3D, which are spherical coordinates. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.